computer, yay. All right, so let's go here. I'm gonna go here, see what happens. And I'm gonna go here. I think this is wrong class. So go to business calc. So there was a worksheet that I had handed out. We went over a little bit of it, and I asked y'all to take a look at it. Let's see, 29th. No. It's in the wrong week. It's in week 3. Algebra review. There's Keith. Cool. Got everybody. I like that. I like when everyone makes it to class. So what I'm opening up right now is, this was the sheet that I want to make sure we feel good about. Let's take a look at those first 10 problems. Are there any of those you would like to see me work out?
Number 8.
Which one?
8.
Number 8, you got it. Anything else off just those first 10? Give it another 10 seconds. We're good there? All right, let's scroll down to these 6. Is there any of those you would like to see worked out a little bit more extensively?
13.
13, you got it. Anything else, my friends?
14.
14, you got it.
15.
15. We're good with those? So I got 8, 13, 14, 15 so far. That's a great start. Thank you. And then 17 through 23. Any of those you want to see?
Uh, 22, please.
2. Anything else up through 23? And then 24, 25, 26.
24.
24. Okay. Anything else, my friends?
Could you do 25 also?
Sure. Anything else? I'll do 26 because I'll show you how I was going to do it on the computer. And I think that was it. Cool. I stopped sharing this screen. So I hope you all enjoyed the Thursday or Friday kind of little different way of thinking about stuff, and happy to always, let you know more about what I have done. And, obviously as you are starting to become young adults and getting into your adult lives, there's definitely the thought process of saving is definitely something that is important to do. All right. So I am going to, let's see, I'm going to share this screen. All right, that looks like it showed up. So problem number 8. So number 8 will not work with Desmos, and it won't work on your graphing calculator because there's 2 variables in there. Okay, though it is, if it was equal to a number, we could indeed solve it, but we just really truly want to factor it. So you're going to look at the 2 and it's like, I have a 10 and a 15. I know a 5 can come out. I have x to the 3rd and x to the 4th, so I can factor a maximum of x to the 3rd out. I have y to the 2nd, y to the 3rd. I can factor a maximum of y to the 2nd out. All right, so if I factor a 5 out of 10, I'm left with 2. If I factor an x to the 3rd out of x to the 3rd, there's nothing left. If I factor y squared out of y squared, there's nothing left. The plus sign comes down for the ride. If I factor 5 out of 15, I have 3 left. If I factor x to the 3rd out of x to the 4th, leaves us 1 of them. If I factor y squared out of y to the 3rd, it leaves me a y. And so that's your whole answer there. Oh, hey, Jacob, I got a request for a camp or something like that for you.
Oh, yeah.
So I gave you all good marks.
Well, I appreciate it. I meant to email you, but it must have slipped my mind. Sorry about that. That's my fault.
I kind of figured out what it was for, so I wasn't too worried about it.
Yeah.
No big deal. So
I really appreciated your opinion.
Happy to do it.
So.
Happy to do it. All right, are we good with number 8? All right, so then the next one we wanted to take a look at was problem number 13. Okay, so number 13, I'm actually going to stop sharing this screen and take a look at problem number 13. What I'm going to do is I'm going to bring up Desmos on this computer. So all right, share screen, Desmos. So problem number 13 said you have 11 raised to the x minus 1, and you have 11 raised to the 2 parentheses x minus 5. So what you're going to do is you're going to kind of cheat the system a little bit, and you're going to use the graphing calculator. So there, right now the problem doesn't have y as any part of it, but we're going to use y equals twice. Whoops, how is that working? Y equals. So we have 11 raised to the x minus 1. Oops, I need to put that in parentheses on Desmos. Sorry about that. X minus 1. So it's going to give us this kind of graph. And then we're going to, let's see, I got to go to projector mode. It makes it a little fatter, so it might come up on your screen a little bit better. And then the other equation, the other side of it, I'm going to have y equals, I have 11 raised to the, and they have 2x minus 5. So if I distribute that over, 2 times x minus 5 becomes 2x minus 10. Close parentheses. And then what we're looking for is where do they cross each other? And it's kind of hard to see where they cross each other, but we're going to start zooming in with Desmos. And it looks like the red is just above it here. Bet you if we came this way, let's see. 2x, write this out real quick. Is that right? Positive 9. Oh, it actually goes the other way. It goes to positive 9. Nope. I'm off. Subtract x. Let's see. 11 raised to the x minus 1. 2x minus 10. X minus 1. Both 11 base. Oh, I'm trying too hard on this one. I'm going to stop sharing here. Share back here. Being that we have the same base on both sides. I'm going to set the exponents equal to each other only. I don't have to worry about the bases. So I'm going to distribute over here. And then just solve it by regular algebra. So that's going to give me x equals 9. And that's how you'd solve that problem. Got a little trickier how I wanted to solve it. Number 14 might be one you might want to look at it this way. Let's make 9 and 27 the same base. So I know that 9 is the same thing as 3 times 3, which is equal to 3 squared. I know 27 is the same thing as 3 times 3 times 3, which is 3 to the third. So I'm going to rewrite 9 as 3 squared, and then that's going to be raised to the x plus 4. So I'm going to multiply by x plus 4 because exponents, when they're on top of each other, they multiply. 27 is 3 to the third, and I'm going to set that times x minus 3. Being these bases are the same, I'm going to set my exponents equal to each other. So I'm going to get, do it twice. I'm going to distribute over here, so I get 2x plus 8 equals, and then distribute here 3x minus 9. Subtract 2x from both sides. Add 9 to both sides, so x equals 17. So that's a simple way. The main thing you have to remember on this is I can break 9 and 27 down into base components so they can become the same. And then number 15, we'll go back to Desmos. 15 will work out nicely on Desmos. Share screen. Go here, share. All right, so on Desmos for 15, I'm going to go get rid of both of those. Y equals the left side, which is 4 raised to the x. And then my other equation is y equals 51. So y equals 51 is a horizontal line way up at 51. So what you could do is you could zoom out on Desmos a few times and then just start rolling your screen. Now you notice you have the 2 intersections. So we're only concerned about the x value. So the answer to number 15 is 2.836. You do not need to put the y component because there wasn't a y component in the original. Okay. So that takes care of our front page. Was there anything of those problems I worked out that you need a little more clarification for, my friends?
Sorry, could you do 16 too?
16 as well? Yeah. Share screen. So 16, I think we could do with the Desmos as well. So I'm going to clear those both out. So my left side is going to be, I'm going to incorporate y. So I have 2 raised to the parentheses x minus 5. Oh, not x equals 5, the minus 5. Okay. Now I have that plus 3 there. So if I were to subtract that 3 to bring it to the other side, I would have 27. That you'd go 30 minus 3 to get 27. There you go. Y equals 27. Y equals 27 is a horizontal line. So you just bring your controller down, click right on top of it. And so you look at only the x component of that answer, which is 9.755. Does that make sense? Okay, turning the page. All right, I'm going to stop sharing here and go to my other board. Can't really see it real good, so I'm just gonna stop share, share. Oops. Smartboard. There we go. Share. All right, so number 22. Let's find it. It's on the second page. 22 says they want g of 5. So I'm going to take this equation here, and I'm going to plug 5 in for x. So I get 2 times, there was an x there, but now it's going to become a 5. So that gives you 10 plus 5, which is 15. Okay. And then 24. 24, first off, I'm going to use the g at x. I'm using this equation. And we're going to modify this equation. So the first thing says g at x plus h. So think of my g function. There was an x in those parentheses, so now I'm going to put x plus h in there. Okay, so this was just x originally. Now I'm going to plug x plus h in. And then I'm going to go ahead and I'm going to subtract g at x. So I'm going to subtract g at x, which is 2x plus 5. Make sure you put that in parentheses because you want to distribute that negative over. And then you're dividing everything by h. There's no other h, so you just have to plug it in. From there, we're going to just distribute over the parentheses. So that's going to give me 2x plus 2h plus the original 5. Distribute the negative over the parentheses. Minus 2x minus 5, all divided by h. You're going to look for your like terms and cancel. So 2x and negative 2x, they cancel each other out. Positive 5 and negative 5, they cancel each other out. So you wind up with 2h over h. Well, the h's cancel out, so your resulting answer is 2. So there's a lot of meat and potatoes with that one. So if I gave you something like that on a quiz, I would have a worked out similar version I would have up on the board so you could take a look at it, okay? But the main thing on that one is remembering to plug in the x plus h for x and then distributing the subtraction sign over the equation. A lot of people forget to distribute the subtraction sign and then they get too much as part of their answer and it's like, well, this doesn't make sense. Like you forgot to distribute the negative over, okay? Problem number 25. We just want to write the quadratic function with these roots. So I have 5 and 1, so I get x equals 5 and x equals 1. Well, I'm going to make these equal to 0. So I'm going to subtract 5 to get that one, and I'm going to subtract 1 on the other one. And then I'm going to go ahead and FOIL this together. So that's going to give me x squared, outside, inside, last. Combine your like terms. And that's my answer for number 25. And then problem number 26. I just wanted, there's definitely a couple ways you could do it. You could do substitution, you could do elimination. But what I would use is I'm going to go ahead and plug it into Desmos. So I'll come back over to this one. And you're going to plug each equation in just as they sit, where you have both x and y in there. Oops, can't see that. Come on. So 26, you're going to plug in 2x plus 3y equals negative 13. There's your first equation. And then you have 4x plus y is equal to negative 1. All right, and then you kind of have to find it. So if you hit the home button, it takes you back to the thing. So now you're just looking for it intersects. Now, being the original problem had both x and y in it, you want to have the entire point as your answer. So your answer to that one entirely is x equals 1, y equals negative 5. Okay, as a point x comma y. So that's why you get x equals 1 and x equals negative 5. Seem okay? Everyone happy? Was there any other questions that came off this sheet that you need a little bit more guidance on? If not, everyone's getting the points put in for that one, which is good. I think tomorrow or Wednesday, I'm gonna have a one question, really small quiz, and it's gonna be just like the problem number 24. Does anyone want to see number 24 worked out, or another version of number 24 worked out?
Yes, please.
Yes, please.
This is, you will see this on the quiz. Now, this is not the exact question. If I make the exact question on the quiz, that means I forgot what I gave you, but you know, life happens that way sometimes, right? And the quiz tomorrow will be on your own. Okay? Not going to be working with each other, okay? So you will see a problem very similar to this, and we're going to give you this equation. So this will be what we want to find. Now, we might give you an equation that looks like this. Oops, can't be f at x because we're using g at x. So g at x is equal to, let's go with 2x squared plus 3x plus 5. Okay? So this one's has a little bit more meat and potatoes to it than the original. Agree? But we're not going to let it panic us. So I'm going to go 2 parentheses, quantity squared, plus 3 parentheses, plus 5. So that takes care of this once I plug this in. Is that okay so far? So then I'm going to subtract g at x. So I'm going to subtract everything I have there. And it's all going to go over h. Is there any part of that math that I need to clarify a little bit more? I haven't got it worked out yet, but is there anything that I could clarify a little bit more for you? Seem okay? All right, so now this is where you kind of have to understand how some algebra works. So I'm going to take x plus h squared, which is the same thing as x plus h times x plus h. I'm going to FOIL this out. So I'm going to get x squared plus xh plus xh plus h squared, which means that's x squared plus 2xh plus h squared. So I'm going to replace this. That's going to go back in for that whole thing right there. Make sense? All right, so I'm going to go 2 times x squared plus 2xh plus h squared. I'm going to distribute positive 3 over the parentheses here, plus 3x plus 3h plus 5 comes along for the ride. Uh-oh, ran out of room. Jacob, why'd you let me run out of room this time?
You know what? That's entirely on me. I thought you could have squeezed it in, but you know.
I'm going to squeeze it right here.
That's my bad.
I'm going to move this right down here. So I have some more room. And then I have to remember what I have upstairs. So I'm going to distribute the negative here, here, and here. So that's negative 2x squared minus 3x minus 5. And everything is going to be divided by h. Does everyone see how that worked out? I know I kind of, is that, anyone have any questions on what we just did? Okay. I'll move it down. I'm gonna extend the page. So let's take care of the parentheses. So I'm gonna distribute 2 here, here, and here. So I have 2x squared plus 4xh plus 2h squared plus 3x plus 3h plus 5 minus 2x squared minus 3x minus 5 all over h. Okay, so there's kind of a lot there. So let's start canceling some stuff out. 2x squared minus 2x squared. Those are gone. Okay, what else? I have a 3x and a negative 3x. Those are gone. I have a 5 and a negative 5. Those are gone. I have no more like terms. So I have 4xh plus 2h squared plus 3h all divided by h. So all 3 of these terms have an h that I can cancel. So I get 4x plus 2h plus 3. And then you're going to say, well, that's the same thing as 4x plus 3 plus 2h, and you're all done. Does anyone want to see another one like that? So this is definition of a derivative.
Yes.
You want to see another one? This
Yeah,
is,
please.
yeah, we're good? Or do another? Do another, please. Okay. All right. So again, we're going to use this equation. Notice I changed it from g at x to f at x. And we're going to say that f at x is equal to 10x minus 7. Okay? So if we're going to start filling out this equation, I want this. So I'm going to go 10 parentheses minus 7. Inside here is going to be x plus h minus whatever f at x is. Don't forget to put it in parentheses. All divided by h. So I made this one a little simpler. I didn't make it squared. I just kept it as a linear equation. Distribute the 10 over the parentheses. Minus 7. Distribute the negative over the parentheses. It's all over h. All right, so 10x minus 10x, they cancel. Negative 7, positive 7, they cancel. So this comes out to 10h over h. H is cancel. 10's my answer. We A-okay with that, my friends? So we would have one similar to that tomorrow. But what I'm looking for is I'm looking for all the steps. I'm not looking for just what you think the answer should be. So I want to see the steps. So I will put on the quiz. This quiz will be worth 5 points. 3 of the points come from you showing some steps. Okay. All right. Let's see what else we got. I want to go back. I got to take a look at this here. I'm just going back into my business calc, seeing where we're at. Let's see. All right. So this will be just some review of notes from Algebra 1. So the first thing I want to do, share that, share, smartboard, share. So let's say I have 2 points given. let's say we had that. And we want to make this a linear equation. Okay. Now we have to remember a linear equation can be written like this, which is called standard form. We can also make it like this, which is called slope-intercept. Or we can make it like this. Which is called point slope. We're going to stay focused on point slope. Point slope would have been your best friend in Algebra 1. Unfortunately, we try and do this too much because the graphing calculator accepts that. Desmos accepts any of them. We also try and sometimes mess around with standard form, but this form, the point slope form, is the most accepted version. So first thing you're going to do when you have 2 points given, you're going to label x1, y1, x2, y2, and we're going to find the slope. So the slope equation is the change in the y's over the change in the x's. So plug in your labeled amount. So you get 10, subtract 3, negative 5, subtract 2. So I'm going to get 7 over negative 7. That's nice. We wind up with a slope of negative 1. Now, when you use point slope, there are 2 answers that seem like they're both the correct answer. Okay, and they're both right. The reason why this answer is going to work is if I plug in, when I plug in a point slope, I'm going to plug in here, here, and here. So if I use this as my x1, y1, my answer is y minus 3 equals my slope, negative 1, x minus 1. That answer is 100% correct. Now, we're going for a fancy color. Ooh, I like the hot pink. We're going hot pink. Is that all right? So let's say I use this as my x1, y1. I'm going to plug this in. So I'm going to get y minus 10. My slope is still the same. And then I get x. If I plug a negative 5 in, it's going to change the sign. So I get x plus 5. Both of these answers, my friends, in point slope, they look very different than each other, but both of these answers are 100% correct. There's not one that's more correct than the other. And I know some of you might be looking at it going, but they're 2 different answers. You're right. We have it in point slope form. Point slope form is the most accepted form of linear equations worldwide. Okay. Again, we went to slope intercept back in the 90s when the graphing calculator came out, because the graphing calculator only takes it as y equals. Okay, so that's why we got so heavily invested in slope intercept. And then standard form was just its own entity. Now, standard form is also very much accepted worldwide. The one that is the least most accepted worldwide is the one that we taught the most, slope intercept, because we're trying to program you into realizing, oh, I have a graphing calculator, TI has this, so it's Texas Instruments' fault. Now we have Desmos that allows you to plug it into any form. TI hasn't caught up with this thought process yet. So both of those answers are the exact same. And I'm going to show you why they're the exact same. But if I said, hey, leave your answer in point slope form, it's one of those 2 answers that you're going to put. Okay, and it all depends if you labeled your point x1, y1, or if you labeled your other point x1, y1. Now let me show you why these 2 points are the exact same. If we went back and said, okay, Texas Instruments, you're the wise one. So I'm going to distribute negative 1 here and here. Negative 1x was just negative x. Negative 1 times negative 2 is positive 2. Add 3 to both sides. Y equals negative x plus 5. So that's the slope intercept form of the point slope form. Or on this one, I'm going to distribute -1 here and here. I'm going to add 10. And lo and behold, I get the exact same answer. So that's why the point slope answers work. So this answer is 100% correct, and this one's 100% correct. Okay, if you left them in point slope form, you're totally correct. Okay, so that's the first thing. Now, we're going to start getting into graphing a little heavier types of problems. So let me stop sharing here. And I just want to make sure you feel comfortable with Desmos. Now, again, a lot of you already loaded the Desmos on your phones, which is great. You can always use that in class. If you don't have it on your phone, that's okay. You can always use one of my Chromebooks, which I know they're so fancy, and they keep locking it like kids are going to run away with them. I imagine if you went into a pawn shop, you'd have to pay the pawn shop to take it from you because they are old, they don't work. But you can always use one of my things, or if you have your own computer, you can always use your own Desmos in my class. But let's talk about this equation. So let me go to screen share. Hang on, cancel. Got to go on to back to Desmos. Clear both those out. And oh, there you are. Screen share, share Desmos. So let's put a problem like this up. Let's say we have y equals 5 over x plus 2, x minus 3. Okay, kind of a fun looking graph, agree? Why does it work the way it's working? Any thoughts? Here, I'm going to add a little bit more to it. I'm going to go, let's make this x equals -2. I'm going to make this one x equals +3. And then I'm going to go y equals 0. So let's see. I'm going to see if I can zoom in on this a little bit. Okay. So take a look at our graph. Notice I have those vertical lines. I have a vertical line at the -2. I have a vertical line at the +3. And I have a horizontal line at 0. So what kind of things are taking place to make that happen? Why does that x equals -2? Why is that a significant line? What would happen if I plugged -2 into my equation, my original equation? What would happen to the denominator? What would happen if I plug -2 in for x plus 2? What does it become? So hang on.
Vertical line.
Yeah, so hang on. Let me plug this back in. All right, I'm going to stop sharing here so we know what the picture looks like. Let's figure out why the picture looks that way. So we have y equals 5 over x plus 2 and x minus 3. So when I graph this, I had -2 here. And this one, I had +3 here. And And then I also had one last little part, which was this. And so my graph kind of looks like this. So what, if I were to take 3 and plug it in right here, this would give me, if I plug it into my x's, I'd get 5, 3 plus 2, which is 5, 3 minus 3 is 0, so this becomes undefined. And if I were to take this -2 and plug it in here and here, I get 5 over -2 times 2 is 0, -2 minus 3 is -5. So I'm dividing by 0 again, so it becomes undefined again. So we have 2 undefined terms. That's why we have these vertical, we're going to call these 2 lines vertical asymptotes. Okay, vertical asymptote, we will approach it. So what's happening is as I, on this portion of the line right here, let's highlight this. Let's highlight this region here. So as I travel along this line this way, in the x direction, I'm getting closer and closer and closer to -2. So I get close to -2. I approach it. I don't get to it. Okay? That's the same thing over here. If I'm going this way in the x direction, I'm going up this graph. So I'm getting closer and closer and closer to +3. So I guess it would be x equals 3 and x equals 2. Okay? But then something happens down here. As I'm going this way, if I start coming in, this way I'm getting closer and closer and closer to 3. And if I go this way, I'm getting closer and closer and closer to -2. So I have a vertical asymptote that's taking place. The horizontal asymptote, the reason the horizontal asymptote is taking place was there's some rules in Algebra 2 that we covered. If the degree on top is less than degree on bottom, then the line y equals 0 is a horizontal asymptote. Okay. So that's kind of where we're going to start building into. And don't panic if you're not able to figure this out. One, I will always allow you to use Desmos. So when you graph it, if you graph it correctly on Desmos, you can see the graph. But then we're going to start talking about what happens as we approach stuff. And, in calculus, there's something called the squeeze theorem. They also call it the fly-swatter theorem. And it's as you're approaching something, and as you approach something as a asymptote, means you're talking about a limit. You're coming closer and closer and closer to something, but you're not quite getting there. So something happens as I approach from going to the left. Some happens if I approach it to the right. Sometimes it's the same point you're approaching as from the left and right. But on this one, if I was approaching +3, if I was coming from the left, it's at positive infinity. If I was approaching from the right, it goes to negative infinity. And then we're talking about what's going on in the y directions. So my friends, we are out of here at what time? 36. Hang on, I cannot see my board. Yeah. Hey, so friends, we're out of here. I'll see you tomorrow. I'll give you the one or on Wednesday. I'll give you the 1 question quiz tomorrow, and it's on your own. 1 whole question. It's worth 5 points. 3 of the points showing the steps. Okay. That's all I have for you guys and girls. My friends, have a great day. Take care of one another.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Bye.